Let's start with going the other way. We were expanding, now we're going to condense. All right, so let's start with number 33, the first condensing problem. Log base 4 of 7 minus log base 4 of 10. All right, well, we have subtraction here. Okay, so condensing would be, if expanding is going from the left to the right of the properties, then condensing would be going from the right to the left. If your expression that you're looking at looks anything like the right side of a property, make it look like the left side of the property, and you'll be condensing. So this expression uses subtraction, and subtraction is only used in the quotient property if you're looking. So the quotient property would tell me to write it as the log base 4 of the first thing in the numerator over the second thing in the denominator. And that's it. This is just, condensing is easier to know that you're done. Once you have the log of a single thing, you're condensed. It's all condensed. Expanding is a little bit, it seems more ambiguous, but it's not. But definitely condensing is more clear, right? If you're adding two logs together, you can't have two logs. Let's have a single log. If you got a number out here multiplied by the log, don't have that. Have just start when you start saying the expression that's been condensed, you say log. That's the first thing you say. You don't say 2 times log, and you also don't add them together or subtract them. Okay, so let's go from 33 to 36. 6 times the natural log of x plus 4 times the natural log of y. You might look at the addition first and say, great, let's use the product property, and let's go. But don't go, not yet, because the power property is for things that look like this. I hope I'm not covering that up, where it's just the natural log of x plus the natural log of y, right? But that's not what this is. This is 6 times the natural log of x plus 4 times the natural log of y, and nowhere in the product property do you see numbers being multiplied by the natural log, or whatever log you're using, whatever base of the log you're using. So we need to make it look like that. So to make it look like that, what do you think we're going to do? Well, we're looking and we see, oh, the property that has multiplication in front of the natural log or the log, you use the product property. So the natural log of x to the 6th plus, use it again for this one, natural log of y to the 4th. Now I see addition, I'm adding them together. Addition would be, and it's just the natural log and the natural log, right? Addition would be the product property, so it's the natural log of x to the 6th, y to the 4th. Okay, and you don't put these together in any way, you can't combine them. It's just x to the 6th times y to the 4th. It's not like xy to the 10th or xy to the 24th or anything like that. It just stays the way that it is. Let's try 39. Natural log of 40 plus 2 times the natural log of 1/2 plus the natural log of x. Nice big long expression here. I would want to just go ahead and use the product property a bunch of times, except for I've got this guy standing in the way. So let's first solve that problem. This 2 multiplied is a problem. Okay, so let's handle that. Natural log of 40 plus, let's use the power property. Say the natural log of 1/2 squared. 2 becomes the power now. So natural log of x. Now we've got 3 additions, which means we would have, by the product property, 3 multiplications. It would be the natural log of 40 times 1/2 squared times x. Now let's handle this. Let's simplify all of this. This is the natural log of, well, what's this first of all? 1/2 squared. That's 1/2 times 1/2. Since we are experts at multiplying fractions together, we know we multiply straight across, and this little bit is the same as 1/4. So 40 times 1/4, or 40 divided by 4, is 10, And then 10 times x is just 10x. Natural log of 10x. All right. Now let's see. Should we try another? I think we should. I think we should try 42. 2 times the quantity, log base 3 of 20 minus log base 3 of 4 plus 0.5 times log base 3 of 4. Wow. Okay. Now, we want to get this all so that it's, like I said originally, just the log of this base, log base 3 in this case, of just a single thing, right? So I got to put all these guys together. Man, seems like kind of a chore. But it's not too bad. What should we do, right? First, we should have an expression that looks more like this, where I've got, like, just no parentheses, nothing like that, just, you know, the log and the log and the log. But this is a little different. What do I do about this 2 is the question. I see, you know, right offhand, 2 ways basically you could do this. You could work inside the parentheses and combine these together. You could, which is what I'm going to do, you could also take this 2 and use the distributive property and distribute the 2, get 2 times this and 2 times this. But I'm going to tell you, if you do the parentheses first, like the order of operations says you should, then it'll be faster. The other way is not incorrect. That's my big deal with things like order of operations and PEMDAS, and it kind of restricts you from thinking things through. You could do the parentheses first. You could also multiply these first, as long as you're just following the properties, you're applying them correctly. Anyway, I'm digressing. So let's work with the inside here. This is going to be 2 times the inside, right? And so what do? I have subtraction, and I don't have any numbers out here, so I don't have that to worry about. So it's subtraction is the quotient property, so log base 3 of 20. I would write 20 over 4. What's 20 over 4? 20 divided by 4 is 5. Plus 0.5 of, or 0.5 times log base 3 of 4. Okay, so we've got 2 times log base 3 of 5, right? And these parentheses are kind of irrelevant. I don't need parentheses. They're not irrelevant. They're redundant is what they are. So I've got 2 times log base 3 of 5. Let's look at that. What do? That's the power property. So this becomes log base 3 of 5 squared plus, okay, let's look at this 0.5. Okay, I want you to think about a lot of things in your head all at once. I'm not going to write all these things down because I'm running out of space. All right, what do I do here? Well, I've got a coefficient. The coefficient is now going to become the power by the power property of logarithms. So it's like, what's that going to be? It's log base 3 of, let's just think about what's right here. 4 to the 1/2 power. 4 to the 0.5 is 4 to the 1/2. What's 4 to the 1/2? Remember from our rational exponents and nth root chapter that 4 to the 1/2 is the same as the square root of 4. What's the square root of 4? The square root of 4 is 2. So what I have altogether is log base 3 of 2. All right. So now we're going to have to think about some things altogether again. We got the log base 3 of 5 squared plus the log base 3 of 2. So what do? We have addition. That invokes the power, or not the power, the product, the other P one. The product property. That's going to be the log base 3 of 5 squared times 2. So that's going to be the log base 3 of 5 squared times 2. 5 squared, what's that? It's 25. And so we have 5 squared times 2. That's 25 times 2. That's 25 times 2 is 50. So put it all together, you have log base 3 of 50. And that is condensing. Let's see. Change of base. This is really, get out your calculator and use the change of base correctly exercises. So let's do 45. 45 says log base 4 of 7. Okay. Now, if this were on a test, and I were testing you, which is what I do on tests, is what I would say, is if you could analyze this without a calculator, I would expect you to do that. I would say, tell me the power of 4 that gives you 7. 4 to the what is 7? Of course, the problem with that is I don't know what the power of 4 is that gives me 7. It's not as big as 2, because 4 to the 2 is 9, so it's going to be less than that. It's going to be between 1 and 2, but that's pretty much all I can deduce. So what we do is use the change of base formula. Change of base formula. Use the log or the natural log. It doesn't matter. Either way, right? So I'll use log base 10 first, and then I'll use the natural log as well. So log base 10 of 7 divided by log base 10 of 4. Apparently 1.4-ish is the power of 4 that gives me 7. 4 to the 1.4 and all that is 7, apparently. Let's try the natural log. The natural log of 7 divided by the natural log of 4. Same exact thing, which shouldn't be a surprise. Okay, let's try 49. Log base 3 of 6 equals, alright, so here we go. The log of, the way that I think the easy thing about the change of base formula is to remember it's the log of one of them over the log of the other one. A lot of time people will get that confused. Which one's on the numerator, which one's in the denominator. So the way that I remember is, the numerator's on the top of the fraction, and this number is bigger, it's higher up in the way that we write this, so that helps me remember that this will become the numerator, right? And then this will become the denominator because it's farther down, and then the denominator is farther down. So if that helps you, then that gives me great joy. Log of 6 over the log of 3, making sure you use the same base here. Don't do the log of 6 and the natural log of 3. That won't work. So 1.63 is about what we're looking at. Just, again, try natural log of 6 divided by the natural log of 3. 1.63 again. Exact same thing. Not a surprise. Let's try 58. I should write it down. Log base 2 of 15 sevenths. Log base 2 of 15 sevenths. What's the power of 2 that gives me 15 over 7? My goodness, I have no idea. So, of course, saying I have no idea is not reason enough to take out the calculator. But it's really not reasonable. I just don't know what the power of 2 is that gives me 15 over 7. I know that 15 over 7 is close to 2. It's a little more than 2. But it's not 3, and it's certainly not 4. So, I don't know. It's just a number that's a strange number that I'm just going to use my calculator to find, because it's not a simple one. So let's try a log. Just choose one of them, not log or natural log. Log of this whole thing, of 15 over 7, divided by the log of 2. Log of 15 over 7 divided by the log of 2. Okay, that's 1.0995. So really it's going to become about 1.1 when we round to 2 or even 3 decimal places. 1.1. Okay, that should make it pretty clear just how to use the change of base formula, and that's all we're trying to do. Just how do we use this? Okay, well, I will see you next time.